Welcome back, students. So now, in the first half, we have discussed what is resonance. Okay. Now we are going to discuss the conditions for writing the resonating structure. Conditions for writing the resonating structure. For writing resonating structures. So the condition is conjugation. Student, are you getting the conditions for writing resonating structure is conjugation? So which type of conjugation? Now remember, pi bond in conjugation with pi bond. Pi bond in conjugation with positive charge. Pi bond in conjugation with negative charge. Pi bond in conjugation with lone pair. Then pi bond in conjugation with free radical. Then positive charge or vacant orbital in conjugation with lone pair. Student, quickly note down. These are the conditions which can, by which we can draw the resonating structure. We can draw the resonating structure. Quickly note down. Student, am I audible? Can anyone write in the chat box? Other students, quickly note down.
In progress.
Quickly note down. Okay. Achha. Next. Suppose I'm just going to structure draw kartile. Suppose you are drawing okay. So how to draw the resonating structure? Now here, oxygen is more electronegative than carbon. So shared pair of electron will move towards oxygen. Then this, it is CS2. CHCO minus H. So here it will be double bond. It will be plus charge. Similarly, positive charge or vacant orbital in conjugation with lone pair. So oxygen contains lone pair. So you can draw the resonating structure. This, it is CH2 double bond OH plus free radical. So it is known as allyl free radical. Allyl free radical. So it undergoes homolytic cleavage this way. Undergoes homolytic cleavage this way. So it can make CH2 dot CH double bond CH2. All of you got this? So these are the ways by which you can draw the residue structure. As a one more structure. Nitrobenzene. Take 2 minutes and draw the residue structure of nitrobenzene. All possible residue structures of nitrobenzene. Quick. All possible residue structures of nitrobenzene. Quick. All of the writing. Here, this one, oxygen is more electronegative than nitrogen. So the structure can be again positive charge in conjugation with pi bond. You can continue the structures. Again, positive charge in conjugation with okay. Then the electron will come back. So the last structure can be quickly draw. Completed, students? These are the residue structures of nitro benzene. If any difficulty, write in the chat box. Okay, done. Good, Sumit. Okay. After this, now, after this, now, what are the stability of resonating structures? Stability of the resonating structures. We know the resonating structures have comparable stability and comparable energy. Again, repeating, the resonating structure have comparable stability and comparable energy. So still, we can arrange the energy of the resonating structures. Still, we can arrange the energy of resonating structures or stability of the resonating structure. So there are certain rules. First, aromatic structure is more stable than non-aromatic structure. Aromatic resonating structure is more stable than non-aromatic resonating structure. Jamuna, we have already discussed what are the conditions for resonance. Means resonance, where the resonance can take place. The condition is conjugation. So just you can see, I have written conjugation. So pi bond in conjugation with pi bond, positive charge, negative charge, lone pair, free radical. Pi bond conjugation kichi bhi rahibo, that will make the resonance to take place. Then last one is positive charge in conjugation with the lone pair or vacant orbital in conjugation with the lone pair. So these are the conditions for resonance, means where the resonance can take place. So here stability of the resonating structure. So first is aromatic structure is more stable than the non-aromatic structure. Like this and its resonating structure is CH2 minus CH2 plus. So it is non-aromatic and this is aromatic. So which is more stable? Non-aromatic is more stable, less stable than the aromatic resonating structure. So here structure 2 is aromatic, 1 is non-aromatic. So structure 2 is more stable than 1. Okay. So aromatic resonating structures are more stable than the non-aromatic resonating structures. What about the second one? Second, neutral resonating structure is more stable than the charged resonating structure. Reverse. And another thing you have to be very careful that the points we have to follow serially. The points we have to follow serially. That means we have to see the first rule. If the first rule can decide the order, then we need not to go to the second rule. Sometimes, as the case देखिवा, so second rule is neutral resonating structure is more stable than the charged resonating structure. So in these two cases, जब हमें second rule apply करिवा, first structure should be more stable. So this first rule apply kariba, second structure is more stable. So which rule we have to follow? Serious. That means first of all we have to check for the first rule. If first rule doesn't hold good, then we have to go to the second rule. Okay. So I think it is clear. So neutral structure is more stable than the charge. Next, third, more number of covalent bond, more is the stability. More the number of covalent bond, more is the stability. So it have a covalent bond kaile, which bond we have to think? We have to think for the pi bond. Why? because before some time we have discussed that only the pi bonds do participate in resonance, not the sigma bond. তাহলে আমরা যদি pi bond কে count করিবা, so more the number of covalent bonds, more is the stability. So we can take one structure. So its resonance structure is so 1 and 2. Which is more stable? 2 is more stable than 1. Why 2 is more stable than 1? Because in 2, one pi bond is present, but in 1 there is no pi bond. But in 1 there is no pi bond. Okay. So resonance structure having more covalent bond, more is the stability. This one is clear. So this is the third rule you have to follow. What about the next? Fourth. What is the fourth rule? We know that negative charge can be stabilized by more electronegative element, and the structure in which the negative charge with more electronegative, positive charge with less electronegative, positive charge with less electronegative, it is more stable. If the reverse of positive charge with more electronegative and negative charge with less electronegative, so that becomes less stable. This is the fourth rule. Quickly look at the student. If the negative charge is residing with more electronegative atom and positive charge with less electronegative atom, then the structure is more stable and the reverse is least stable. Quick, note kar diyo. And the last one is we know like charges repel each other and unlike charges attract each other. So we can write more distance between like charges and lesser distance between unlike charges, more is the stability. This is the last one. More the distance between like charges, more is the stability. Lesser the distance between unlike charges, more is the stability. Okay, so these are the rules which explains about the stability of resonating structures. Quickly note down. If a rule विषय कार किसी doubt अच्छी, you can ask me. Write in the chat box. Note कर दियो फटाफट. First rule, okay. Okay, Pushpanjali, what is the doubt? First rule is aromatic resonance structure is more stable than non-aromatic resonance structure. Aromaticity में तो पढ़ी च already. Hockel's rule. So Hockel's rule कौन थिला? Now the structure should be cyclic. First rule, Hockel's rule. Second, it should be planar or nearly planar. Third rule, it should be fully conjugated system. And the next one is it should contain 4n plus 2 pi. Okay, it should contain 4n plus 2 pi for aromatic. So 4n plus 2 pi. N value code start over 0 to start over. So if 2 pi, then that is aromatic. So take for your second structure, it is cyclic and positive charge in conjugation with pi bond. Then it is planarity also there. Then after that, positive charge can be delocalized. That is delocalization or conjugation is there. Then how many pi bonds are there? One pi bond. One pi bond means 2 pi electron. 2 pi electron means it is satisfying or justifying the rule 4n plus. This is aromatic. Aromatic, so that is more stable. So the rule is aromatic resonating structures are more stable than the non-aromatic resonating structures. Okay. Fifth rule, okay, Om Prakash, fifth rule. More the distance between like charges, more is the stability. Lesser the distance between unlike charges, more is the stability. Now we know like charges repel each other and unlike charges attract each other. Again repeating, like charges repel each other and unlike charges attract each other. Okay. Tale, the like charges with a distance adhika thibo. More the distance between like charges. Tale repulsion kam hobo. Lesser the distance between unlike charges. Repulsion kam hobo. Attraction adhika hobo. So that attraction adhika hobe, stability increase way. Repulsion kam way, stability increase way. So this is the answer. Is it clear, friends? So note down. Any other doubt from the stability of resonative structures? No. Okay. Now, complete. Okay. Next, types of resonative structure. Types of resonative structures. It is of two types, plus R or plus M, minus R or minus M. Plus R plus M, minus R minus M. Inductive effect plus I minus I, it is the plus R minus R. So inductive effect plus I minus R consider. Now if the atom or group acquires positive charge, then partial positive, then plus I, and acquires partial negative charge, then minus I. Similarly here, if the atom or group acquires positive charge as a result of resonance, plus R, and negative charge as a result of resonance, minus R. Okay. So, then I'm already dekhiche. Here see, what is the nature of OH group? It acquires positive charge. So this is plus R. What is the nature of CHO group? It acquires negative charge. So minus R. If the atom or group acquiring positive charge as a result of resonance, then plus R group, and as a result of resonance minus or negative charge, then that is minus R group. One is plus R, another is minus R. Okay. So आपको क्या दरकार नहीं? Plus R means the atom or group which acquires positive charge. Minus R means the atom or group which acquires minus R. I don't know why you are writing the unnecessary things in the message. I have told already. Organic chemistry, these are the basic principles. Okay. So basic principle means these are going to be used in the class 12 syllabus. So class 12 syllabus or 11 syllabus with a bridging by general organic chemistry revise karoche. Then next class, next or after one more class, we will discuss the 12 class. So 11, 12 something this is the basics of organic chemistry. Okay. So plus R which parlo. So what are the examples of plus R? OH, OR, NH2. So how to know? Now if the directly bonded atom contains lone pair, if the directly bonded atom contains lone pair, then as a result of resonance, it acquires positive charge, so plus R. Okay. So up to this clear? Or you can take or even halogens. So all these are coming under plus R group. Then minus R group, the atomer group which acquires negative charge as a result of resonance. So negative charge reki asibe NO2, SO3H, then aldehyde, ketone, carboxylic acid, derivative, and this other derivatives of carboxylic acid. So तुम निजे resonance लिखिला परे जानी परिबो if the atomer group acquires positive charge plus R, if the atomer group acquires negative charge then minus R. Okay. So quickly note down. Then we'll discuss the applications of resonance. I hope all of you are writing quick. Okay. Next, applications. First, under the applications, bond length and bond order. Then stability of reactive intermediates. Next, reactivity of haloalkane. This is 12 class haloalkane and haloarine. Next, acidic strength of alcohol and phenol. Then acidic strength of phenol then quickly note down carboxylic acid, basic strength of aliphatic. सब आज डिस्कस करिबानी Over. Then first, that is bond length and bond order. So how resonance is affecting the bond length and bond order? Suppose we are taking a structure. Okay. So if you are drawing the resonant structure of this, it is lone pair in conjugation with pi bond. So it becomes CH2 minus this. So in the first structure, single bond is present between carbon and chlorine. Whereas in second structure, double bond is present between carbon and chlorine. All of you got this? In first structure, single bond is present between chlorine and carbon. Second, double bond is present. So what is the bond order? First, it is neither the single bond nor the double bond. So it is known to have partial double bond character. Partial double bond character. Okay. So the what structure is single bond through out a double bond through partial double bond character. So we know bond order is inversely proportional to bond length. We know bond order is inversely proportional to bond length. So that partial double bond character asks means double bond character develop hoji. Bond order increase hoji. If the bond order increase hoji, then what will happen to bond length? Bond length must be decreased. If the bond order increase hoji, bond length decrease hoji. So this is the first case. Got this? This is the first case. That is bond order and bond length are inversely proportional to each other. ता माने रेजोनेंस जो हबो एटी बॉन्ड ऑर्डर और बॉन्ड लेंथ दीटा को अफेक्ट हबो যদি রেজোনেন্স হবো সেটি বন্ড অর্ডার এন্ড বন্ড লেংথ দুইটাকে এফেক্ট হবো ওকে গট দিস আচ্ছা নেক্সট ওয়ান ইজ the stability order of the resonating structure. It may be carbocation, may be carbanion, may be free radical. Again repeating, it may be carbocation, carbanion or free radical. As a result of resonance, the charges will get delocalized. যদি delocalize হবো, try to understand, যদি delocalize হবো, তাহলে তার availability charge or disperse অধিক হবো, disperse অধিক হবো, তার stability increase হবো. So resonance can increase the stability of all the reactive intermediates. It may be carbocation, it may be carbanion, it may be free radical. Okay. So like if you compare what example now. Okay. So this is allyl carbanion. So it can be stabilized by resonance. It can be stabilized by resonance. যদি resonance হবো তাহলে কোন হলো allyl carbanion এর stability increase হলো. Similarly, draw the resonant structure of allyl carbocation and this free radical. Draw the resonant structure of allyl carbocation and free radical. Okay, wait. Note down. Draw the residue structures. Okay, 13th slide. Okay, wait. This is the 13th page. Quick. Okay, noted. Now, the resonant structure. Here, the resonant structure resonant structures. Okay. Got it? Now, done complete ना करছো? Note कर दियो. Completed. Okay. Next. बाकी जो point रहेला, we'll discuss under the class 12 curriculum. First, reactive of haloalkane and haloarine. आपण discuss करियो haloalkane, haloarine chapter रे. Acid strength of alcohol phenol chapter और carboxylic acid, aliphatic aromatic amine. Okay. So अकेले note कर देचा. We'll discuss under those chapters. Next is hyperconjugation. Before going to that, we are going to discuss some questions. Arrange the stability. First question. Carbocation. So under the carbocation, then second, and all of writing. Second, the stability of carbanion. Take some time. and write okay. Two questions. Two and sub part two. So in total, 4 questions. Take some time and quickly solve. Then are you solving? Then solve color. Write your answer in the chat box. Write your answer. Okay. Aryan, good. Dusman, good. Okay. Shruti, try. No problem. Take some more time. Okay. Nupur completed. Sasi completed. Maheshwar completed. Good. Sumit completed. Who is this Vivo student? Join with your own name. Okay. Now I'm going to write the answer. Then you have to compare. First one. First one is the answer is 3, then 1, 2, 4. Second one is 1, 3, 4, 2. Third one is 2, 3, 1, 4. And the last one is 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 1, 5, 4, 2, 3, 2. So check with your answer. Check with your answer. Okay, good. Look for suddenly. Okay. See, in the first case, it is resonance. It has plus I or hyperconjugation. It is plus R. It is minus R. Second case, it is plus R. It is minus I. It is plus I or hyperconjugation and no effect. Fluorine is minus I. This is minus R. This is resonance. This is plus I. अब effect लिख दियो. अब मैं explain करें minus R plus R. This is plus I or hyperconjugation. This is minus I and minus I. Then you have to remember one point. Halogen thile halogen back bonding भी होगा minus I होगा. But generally हमको ए टाइप रो किसी बेंजीन रे तार substitution आसीबो. Then we have to think for minus I. Okay, back bonding. We have to think for minus I. And again, resonance or hyperconjugation or back bonding is possible at the ortho and para position. Again, repeating, resonance, back bonding or minus resonance, back bonding or hyperconjugation is possible at the ortho and para position. And at the meta position, only inductive effect is observed. It can be plus I, it can be minus I. It can be plus I, it can be minus I. Acha. So which order we have to follow in order to decide the stability order? Acha. So noted. Any doubt in this slide? Quick. No doubt. Okay. Now we are going to discuss the points you have to follow while deciding stability of carbocation. So for stability of carbocation, it is plus R, then resonance, then hyperconjugation. Hyperconjugation discuss kariba. Conjugation, then plus I. Then comes no effect. Then minus I, then minus R. Minus I, then minus R. Okay. Next, stability of Carbanion. Stability of Carbanion. So it is minus R, then resonance, then resonance, or you can take backbone. Then after that, what is the next one? Minus I, then comes no effect, then plus I, hyperconjugation, plus R. Okay. Next, stability of free radical. Stability of free radical. So it is no plus or minus R, only resonance, then hyperconjugation, then plus I, no effect, minus I, then minus R. Minus I, then minus. Okay. So then पचरा जो पर हम देखिबा hyperconjugation तापर हम देखिबा why the order is resonance greater than hyperconjugation greater than inductive effect. तर simple reason हला जदि हम inductive effect resonance भितर compare करिबा, in inductive effect only the partial shifting of electron takes place. It is not the complete shifting, partial shifting of electron. And in resonance, it is a complete shifting of electron. Okay, so obviously resonance is dominating over inductive effect. तापर next देखिबा hyperconjugation and inductive effect. Hyperconjugation हम आप already तुम पढ़ी चाहो तो तुम revise कर दोछे. In hyperconjugation, it is the shifting of electron, but at the alpha position, or that is complete shifting of electron. Hyperconjugation, that is complete shifting of electron. But inductive effect, it is partial shifting of electron. Which is more dominating? Hyperconjugation is more dominating over plus I or inductive effect. Okay, so overall the देखिए resonance hyperconjugation भितर resonance dominating कहीं ना resonance रे conjugation जे पर्यंत से पर्यंत shifting of electron होगा, but hyperconjugation रे it is only up to the alpha position. Hyperconjugation it is only up to the alpha position. Okay, so it is clear. तापर next देखिए, so I hope all of you noted. Note कर सकते student. Any difficulty you are facing? Then the resonance student को किसी किसी confusion हुए. What is the difference between resonance and pulsar? जल्दी हमें आप पूरे example देखी थी ले. ठीक. In allyl carbocation, it is the resonance because it is dispersing the charge. But due to the presence of OH, it is the pulsar effect. Because the pulsar effect or pulsar group or pulsar group जोटा OH को होचे, that is delocalizing the electron. That is delocalizing the electron. Okay. So that is the difference between pulsar resonance or minus R resonance. Complete? Okay, good. Next is hyperconjugation. तापर हम किसी क्वेश्चन देखिबा by taking hyperconjugation, inductive effect and resonance. Hyperconjugation. Hyperconjugation is otherwise known as no bond resonance or sigma by conjugation or by the name Baker-Nathan effect. By the name Baker-Nathan effect. Okay. So these are the three names given to hyperconjugation. These are the three names given to hyperconjugation. No bond resonance, sigma pi conjugation or Baker-Nathan effect. So it is sigma pi conjugation or no bond resonance. If we'll take the structure this. I am going to give one example. Here, CH2 plus means carbon carries positive charge. So positive charge means it is the vacant orbital. Okay, positive charge means it is the vacant orbital. Since carbon carries positive charge vacant orbital, so this sigma bond can be delocalized, can enter into the vacant orbital. As a result, you can write this structure. And it is possible only at the alpha position. It is possible only at the alpha position. Resonance जेमती जेपन conjugation थिला सेपन delocalization होतिला, but it हमें hyperconjugation रे only restricted to the alpha position. It is not even supposed to take place in the beta position. Not even supposed to take place in the beta position. It is restricted only at the alpha position. All of you got this? अच्छा, ताले alpha position ले जो alpha hydrogen अच्छी, that is known as hyperconjugative hydrogen. Hyperconjugated hydrogen. Okay, so you can write more number of hyperconjugated hydrogen. Quickly write down more the number of hyperconjugative hydrogen. Hyperconjugated hydrogen. More is the stability of carbocation. More is the stability of free radical. More is the stability of alkene. More the stability of carbocation, more the stability of free radical, more is the stability of alkene. Okay. All of you got this, students? So carbocation लिखिले ताले एठी हमें गोटे एग्जांपल नै परिबा. Write down the number of hyperconjugative hydrogen atoms present in these carbocations. Number of hyperconjugated hydrogen atoms present in this carbocation. Lekhilo. The question is written in front of you. Note down. Then note karo structure, then write number of hyperconjugated hydrogen. One has written 6902. 6902. Okay, good. Correct answers. See, you can. It is 6 hyperconjugative, 9 hyperconjugative, 0 hyperconjugative, and 2 hyperconjugative. That is the correct answer. So 0 कहेंगे ना जो कार्बन से तो directly हमें third structure जो देखिवा. So this is the carbocation center. So to this carbon is directly attached. So how many hyperconjugated hydrogen? 0. 0 hyperconjugative hydrogen. So this is the answer. Okay. So now the stability of alkene, that is known as Sedgwick rule. So its real name is this Sedgwick rule. Okay, Sedgwick rule. So what is this rule all about? Write down. Write down more the number of alkyl groups. More the number of alkyl groups across double bonded carbon. More the number of alkyl groups across double bonded carbon. Or in other words, more the number of hyperconjugative hydrogen. More the number of hyperconjugative hydrogen, more is the stability of alkene. more is the stability of alkane. Okay. Now, all are isomeric. Okay. Arrange the stability order of these alkenes quick. Next student. Okay. One has written. Okay. Aryan is asking for previous. Aryan, note down quickly. Okay. Now the stability order is, the answer is, suppose you are writing it 1, 2, 3, 4. So it is 1, 2, 4, 3. 1, 2, 4, 3. Why? Because the hyperconjugate hydrogen देखिबा 12. This is 3 plus 3 plus 2, 8. And in both the cases, 4. Along with this is cis, geometrical isomer cis, and this is trans. Cis and trans. Okay. So between cis and trans, so trans is more stable because in cis it is showing more steric hindrance because bulky groups are present on the same side. So it is showing more steric hindrance. So I think all of you got this answer. Okay. Now we are going to discuss some more questions. Arrange the stability. Next, write down the questions. I hope all of you are writing. Okay. So take some time, write down the questions. Try. Om Prakash, what are you asking? Should I write the answer or you want some more time? Okay, sure. Take 2 more minutes. Then how many have completed? Raise your hand. Okay, Shashi complete. Other students? Mention how many have completed. Okay, good, very good. So now I'm going to discuss. So first, the answer to the first question, 4, then 1, then 2, then 5, then 3. And it is 1, 2, 3, 4. And here it is 2, 3, 4, 1. Now compare with your answer. Compare with your answer. Okay. So how many of you did all the 3 correct answers? Okay, complete. Now, if you'll see,